In this section, we are going to be taking several of the skills that we've learned in this unit and just applying them to a variety of situations. So this section is intended to make you think, make you use your skills in a variety of ways. So let's just do some examples of what I'm talking about. In number 1 here, we are asked to find the value of k, and that makes me go and look at the function, and sure enough there's a k in this function. Find the value of k given that 3 is a root of this function. So if 3 is a root, then I know that f of 3, if 3 is a root, we know that that is when the function is 0. So that tells me that f of 3 must be 0. Okay, so we have a choice. We could put 3 in for every x and then set that equal to 0, solve for k. And that would be perfectly fine to do. However, we are going to be having some bigger numbers to raise to powers and combine. The quicker way to do this problem is with synthetic division, because the remainder needs to be 0. Remember that the remainder, using synthetic division, the remainder is the function value at that x value. So that's the way I'm going to do it, just to save some time and save myself from having to raise 3 to the 5th and add it to 3 to the 4th and all that stuff. So I'm going to put -2, 4, 8, -3, k, and -2. It's a 5th degree equation, so I should have 6 numbers across, and I do. So I have them all. There's no zeros hidden in there that I need to take into consideration. All right, synthetic division now. So bring down your -2, multiply and add, multiply and add, multiply and add, multiply and add. That's just going to be k plus 9. Multiply, and we get 3k plus 27. Add, and we get 3k plus 25. That's the remainder. Okay, so if 3 is a root, we know that 3k plus 25 must be 0, because there will be no remainder when you divide if 3 is a root. So k here, if we subtract 25 and then divide by 3, we'll have -25 over 3. That's it. Okay, let's take a look at another one. The polynomial function g is an even function. If g of -2 is equal to 5 is a relative min of g, let me get out a highlighter here. First of all, I know that g is polynomial and even. I know that g of -2 is 5, and that is a relative minimum value of g. Think of that as a relative min would be this kind of thing going on, right? Which of the following statements must be true? And I look at the statements, and they're all talking about g of 2. They gave me g of -2, and they're asking me about g of 2. Well, if g is even, so if g is even and g of -2 is 5, if g is even and g of -2 is 5, that means over here, when at -2, we're up here at 5, right? If g is even, then we have symmetry over the y-axis, with respect to the y-axis. So g of 2 must also be 5. Must be 5. Not only that, but if g of -2 is a relative minimum, then since g is even, g of 2 must also be a relative minimum. So let's see, which one is correct here? Well, I want g of -2 to be 5, so not this one, not that one. And I want it to be a minimum value, so A is the correct answer. So in class, I would have you guys do number 3 on your own. The polynomial function h, so you might want to pause, try it on your own, come back, see if you got it right. The polynomial, we know that h is polynomial, which tells me that it is smooth and continuous, and it just tells me something for sure. Okay, h is an odd function. H of 4 is -6, and that is a relative maximum of h. Which of the following statements must be true? Well, h is odd, and h of 4 is -6. Let's plot that. H of 4 is -6. Down here, -6. And h is odd, so it has origin symmetry. So what is h of -4? Well, h of -4 must be 6. Not that one, not that one. Okay? Now, this is a relative maximum. This is a relative maximum value. Okay? So what would this be if h is odd? Well, if h is odd, this will be a relative minimum value. So, a relative min, because it has origin symmetry. C. Okay? Alrighty. Number 4. P is a 4th degree polynomial function with roots of 1 plus square root of 2 and 2 plus I. Write P of x in standard form. If 1 plus square root of 2 is a root, then I know that 1 minus square root of 2 is also a root. If 2 plus I is a root, then I know that 2 minus I is also a root. Okay? So, you know what? I'm going to go back there and change this problem slightly and say polynomial function with integer coefficients. Integer coefficients. Because, here's why that's true. The conjugate, the theorem that says that these are, the conjugates occur is only if we have integer coefficients on the polynomial function. So I need to go back and change that, add that to it. Okay, so let's see. I know that P of x then, if 1 plus square root of 2 is a root, then the factor will be x minus that root. I'm going to use parentheses because of the minus right there. Okay? Now I'm going to go get this one. So x minus 1 minus square root 2. X minus 2 plus I. And x minus 2 minus I. And we're going to have fun with multiplication here. Multiplication of these things. So, let's just get going. First, I'm going to remove these parentheses in each of these. So I'm going to have x minus 1 minus square root 2, x minus 1 plus square root 2, x minus 2 minus I, x minus 2 plus I, just distributing that minus in there. And now I'm going to start multiplying. I'm going to multiply these two together. I'm going to multiply these two together, and then I'll multiply what I get together. All right, so x times x, x times a negative 1, and x times square root 2. Okay, minus x plus 1 minus square root 2, so that takes care of the minus 1. Now minus x square root 2 plus square root 2 minus 2. Square root 2 times square root 2 is 2. Okay, so So that takes care of those two. Now I'm going to go to these two. All right. X times x is x squared minus 2x plus xi minus 2x plus 4 minus 2i minus xi plus 2i minus I squared. Minus I squared is plus 1 because I squared is negative 1. Okay, let's clean up. All right, I might get a different color for this part. I only have one x squared in here, so x squared. I have a negative x and another negative x, so negative 2x. Any other plain x's? No. So negative 2x. Here's a positive x squared root 2 and a negative x squared root 2, so those cancel each other out. Here's a negative square root of 2 and a positive square root of 2, so those cancel each other out, and we're left with a minus 1. Okay. Since these are conjugates of each other, when you multiply them out, you should have no square root of 2 left. You should have none of those left, no square roots left. If you do, you know you made a mistake. It's the whole point of conjugates. Alrighty, let's go do our imaginary numbers. Same thing here. We should have no imaginaries left here. So I have this x squared. I have a negative 2x and another negative 2x. So negative 4x. I have a positive xi and a negative xi. Those cancel each other out. I have a negative 2i and a positive 2i. Those cancel each other out. And then I just have this single, plus 4, plus 1, so plus 5. Okay. Still not in standard form. Time to multiply again. X squared times x squared times negative 4x, x squared times 5. Negative 2x times x squared, negative 2x times negative 4x, negative 2x times 5. Minus. Okay. Negative x squared plus 4x minus 5. Okay. Lots of places to make little errors on, right? Oh, and I can see I said x to the fourth, but I wrote x squared. Okay. Alrighty. I'm taking just a quick look just to see anything else that stands out. Like that 2 stood out to me. Alright, so we have x to the fourth. We have negative 6x cubed. We have plus 4x squared. Let's see. I've got negative 2x plus 4x will be plus 2x, and then minus 5. Lots and lots of places to make mistakes, and I'm taking a look because something about that did not sound right. I don't know why I had 3 regular x terms. It was right here. I think that 8x should have been an x squared, right? Yes, that should have been an x squared. I'm glad I caught this. So let's do it again. X to the fourth, negative 6x cubed. Okay, here comes my x squared. So 5 plus 8 minus 10, right? So 3x squared. Yeah, up. Wait a second. No. Here's this x squared here. 5 plus 8 minus 1. 5 plus 8 minus 1, right? So 12. Goodness gracious. Alrighty. Yes. And now this will be a minus 6x and a minus 5. Whew. Okay, how does that look? There very well may be another error in there somewhere. Okay, I wanted you guys to see this, and I wanted to do it during our notes for today when we're doing this. I'm not going to have you do this because it is just incredibly, incredibly easy to make little errors on. If I give you one of these on a test, it's going to just be a single square root. It's not going to be like a whole number plus or minus a square root. Same thing with imaginaries. I just think that that's a little bit unnecessary. But this is how it would work if we had to do it. Alrighty. Let's take a look at another application, another just random, what can I ask you about? What could you be asked in this unit? Alright, recall from earlier in this unit that for a quadratic function, the second differences in function values for equidistant x values are the same. Do you remember doing that? Similarly, the third differences are the same for a cubic function. Fourth differences are the same for a quartic function, etc. Okay? The table below gives values of some polynomial function p. What is the degree? And since I have some big numbers here, I'm going to let us use our calculator to subtract numbers. Okay? Just to subtract numbers. So, all right, so we're going to go in and find these differences. This might be a good one to do in class at your tables also. Okay, so I'm going to, since I have already done this, I'm going to, and I'm not going to punch all these in, for the sake of this video, I'm not going to punch all these in while you sit there and watch me. So I'm just going to give these to you. This was negative 859, negative 420, and I subtracted 631 minus this, minus 1490 to get that. If you take this and subtract 859, you get that. If you take this, subtract 42, you get that, etc. So negative 167, negative 43, negative 3, plus 1, plus 17, plus 93, plus 277, and plus 617. Okay? Those are not the same. If they were, it would be linear. So over here you might say, is it linear? No, because these are not the same. If they were the same, it would be linear. And by the way, these are equidistant. All of them are 1 apart. So that has to be true to do this. Okay, let's do this. So the first differences were not the same. Let's see about the second differences. This is 436. This is 256, 124, 40, 4, 16, 76, 184, and 340. So is it quadratic? Is the degree 2? No, because those differences also are not the same. Okay, let's see if it's cubic. All right, 256 minus 436 is negative 180. Negative 132, negative 84, negative 36, 12, 60, 108, and 156. Is it cubic? No, because those are not the same either. Let's find out if it is quartic. Okay, negative 132 minus negative 180. So negative 132 plus 180 is positive 48. Negative 84 plus 132 is plus 48. plus 48, plus 48, plus 48, etc. All of them came out to be plus 48. Is it quartic? Yes, the degree is 4. Okay? All right, let's consider the following table. Let's consider the following function for W. And I'm giving you this table, and I'm asking you to complete it. So fill in these spaces. What is the average rate of change of W with respect to X in each of these intervals? So average rate of change, AROC. AROC for this interval. Will be change in W over change in X on that interval. So W of -2 minus W of -4 over -2 minus -4. Okay, W of -2 is 4 plus 4 plus 2. W of -4 is 16 plus 8 plus 2. -2 plus 4 is 2. Okay, this is 10 minus 26 over 2. That is -16 over 2, so that is -8. So this first interval is -8. The average rate of change on that interval is -8. Okay, let's do another one. Let's find AROC, average rate of change, from -2 to 0. So that's change in W over change in X, W at 0 minus W at 2 over 0 minus -2. Okay, W of 0 is just 2. W of 2 is, we just found it, I'm sorry, this should be a -2, I'm so sorry. W at -2 is, we just did find it right here, so 4 plus 4 plus 2, all over 2. So that is 2 minus 10 over 2, that's -8 over 2, or -4. -4. Okay. Let's find the average rate of change on the next interval, 0 to 2. So that will be W at 2 minus W at 0 over 2 minus 0. W of 2 is 4 minus 4 plus 2. W of 0 is 2. Divided by 2. So that will be 2 minus 2 over 2. That is just 0. Okay. What about our last one? From 2 to 4. That'll be W of 4 minus W of 2 over 4 minus 2. W of 4 is 16 minus 8 plus 2. W of 2 is 4 minus 4 plus 2, all over 2. So this is 8 plus 2, 8 plus 2 is 10, minus 2, that is 8 over 2, which is 4. Okay, so we completed that table. Find the first, part B, find the first differences in the average rate of change of W with respect to X in the intervals from your table above. In these intervals, or for these intervals, what is the first difference? Well, the first difference Negative 4 minus negative 8 is positive 4. 0 minus negative 4 is positive 4. 4 minus 0 is positive 4. They're always 4. So notice that these intervals are evenly spaced again. And our function was quadratic. Our function was quadratic. Yeah? Oh, I know I spelled this wrong. Quadratic. Okay, go fix that. Okay. So we found that the first differences were always 4. What can you conclude? What can you conclude about the first differences in the average rate of change of a quadratic function with respect to x over equal intervals? They are the same. Okay? If we found the average rate of change from 4 to 8, I'm sorry, from 4 to 6, from 4 to 6, what would the average rate of change be? It should be 8. It should be 8. Okay? All right. Next example. Moving on. The average rate of change of the quadratic function, the average rate of change of the quadratic function f is 5 on the interval from -9 to -5, and 2 on the interval from -5 to -1. What is the average rate of change of f on the interval -7 to 11? So we're using what we just found out. All right. Let's set up a little table. Help us organize interval and the average rate of change. Okay. The interval, the first interval they give us is -9 to -5. Notice that the distance between those x values is 4. The next one, the next interval is -5 to -1. That we pick up where we left off, and then that distance is also 4. Okay? So the next interval should be -1 to what? Well, the distance needs to be 4, right? So -1 to 3. And then 3 to 7. And then 7 to 11, which is what we're trying to find. Okay? I'll make myself a little table, organize our thoughts. Okay. They gave us that this average rate of change was 5, and this average rate of change was 2. So what is the first difference? The first difference is -3, and we're quadratic, so that -3 must be true for every equal spaced interval. So we must go down 3 to get to the next average rate of change. We must go down 3 more to get to the next average rate of change. And we must go down 3 more to get to the last average rate of change. So the average rate of change on the interval 7 to 11 is -7. This is using what you already know about things, and we did just examine that from that last example. Okay, if we have time during class, I'm going to do this one with you, but if not, this is just really a repeat of things you've already done. Okay, consider this function. Find the value of k given that p of negative 1/2 is negative 4. So again, I could plug in negative 1/2 for every x, set this equal to negative 4, and find out what k is that way. Or you can use synthetic division. Either way is fine. I prefer synthetic division because it is easier arithmetic. And without a calculator, you want to simplify things. I almost missed a 0 for that x cubed. I'm going to make that into a 0 here. Make sure I have all my signs right, all that good stuff. 1, 2, 3, 4, 5, 6, and it's a 5th degree equation, so yes, this is good. Or 5th degree function. All right, pull down 16. Negative 1/2 times 16 is negative 8. Add negative 1/2 times negative 16 is positive 8. Add negative 1/2 times 8 is negative 4. Add negative 1/2 times negative 2 is 1. Add negative 1/2 times negative 8 is 4. Add. That's the remainder. That has to equal this negative 4. So k plus 4 must be negative 4, so k must be negative 8. Okay, find the value of k given that p has a factor of x minus a half. Well, if this is a factor, then I know that p of 1/2 must be 0. And I'm just going to do the same thing I did above, except at the end, I'm going to set it equal to 0. So 1/2, and then all of these values across. I'm hoping I did it right the first time because I'm just copying what I just wrote. And half of 16 is 8, add. Half of 0 is 0, add. Half of 0 is 0, add. That worked out nice. Half of 2 is 1, add. Half of negative 8 is negative 4, add. And we get k minus 4, which must be 0, so k must be 4. Alrighty, just some random problems. One little thing that was new, but mostly just random problems using what we learned in this unit already.